Chandbagh School, Physics Department, Grade 11, and we are going to discuss the problems of self and mutual induction. This is the assignment, but before assignment we will revise the lesson number 21, and assignment is of lesson number 22. In the lesson number 21 we have uh, defined the self induction, and in the previous lesson number 20, we have discussed the mutual induction. So the self inductance or self induction is defined as the induction of a voltage in a current carrying wire when the current in the wire itself is changing. As you can see in the picture, there is a coil and current is passing. The current is alternating current which varies at every instant. So the current is changing, the voltage is changing. Hence in this case, since there is only single coil, so the magnetic field created by a changing current in the circuit itself induces a voltage in the same circuit, in the same coil. Therefore this voltage is called self-induced voltage, and this process is called self-induction. And the principle of the self-induction is again the Faraday's law of electromagnetic induction, which is the flow of electric current through a conductor creates a magnetic field around the conductor whose strength depends on the magnitude of the current. A change in current causes a change in magnetic field strength. So from Faraday's law of induction, any change in the magnetic field through a circuit induces an EMF, electromotive force, voltage in the conductor. This is known as electromagnetic induction. So the changing current induces a voltage in the conductor. This induced voltage is in a direction which tends to oppose the change in the current, change the current. So this was stated by Lenz's law. So it is called a back EMF. Due to this back EMF, a conductor's inductance oppose any increase or decrease in electric current through it. So this is the principle of the induction, electromagnetic induction, either self or mutual. In case of mutual induction, we have two coils. So in first coil, the current is varying, which produce varying magnetic field, and this varying magnetic field when crosses the secondary coil, passes through the secondary coil, it induces an EMF in the secondary coil, and this is called mutual induction. And this principle is used in the transformer. So the basic principle behind the working of a transformer is the phenomenon of mutual induction between two windings linked by common magnetic flux. Basically, transformer consists of two inductive coils. That is, first is primary coil and the second one is secondary coil. The coils are electrically separated by magnetically linked to each other. Actually, they are not touching each other uh, physically or electrically, but the magnetic field is common. Both the coils have the same magnetic field shared. So when there is a change of current in the primary coil, there is change in the magnetic field, and this change is also shared by the secondary coil. The change of magnetic flux in the secondary coil induces an EMF according to Faraday's law of electromagnetic induction. This we have already discussed, and today we are going to revise the same concept by problem solving, and this is called application of mutual induction. In this question, question number 1, an ideal transformer has a primary voltage 600 volt and a secondary voltage of 240 volt. The secondary coil is attached to a transformer to a resistor of the resistance 120 ohm. Now, what is the power dissipated in the resistor and the current in the primary coil? This is a MCQ question. So you need to understand the concept of the transformer, which we have discussed in lesson number 20, and also on the Skype lesson number 15. So you need to revise the lesson and then answer this question. You should answer this question with calculation and justification on the paper. And then you select the option either A, B, C, or D. The second part of the question, again the application of mutual induction. The primary coil P connected to the 240 volt main supply has 8000 turns. The secondary coil S supplies 6 volt to the lamp. So we need to find the number of turns in the secondary coil. So the first question is calculate the number of turns in the secondary coil. Again, you need to understand the transfer of power and from primary coil to the secondary coil and their formula, which we have already discussed. The second part of the question, the current in the primary coil is 0.050 ampere and we need to calculate the power input to the transformer. Now, in the second part of this question, 90% of the power input to the transformer is transferred to the lamp. Means 10% power is lost. So we need to calculate the current in the lamp, which is using 90% of the power from the primary transfer to the secondary. So we need to find the current. Dear student, this assignment you should complete it and you should WhatsApp as early as possible on the CBS WhatsApp group of 11A and 11C. Thank you very much. In the next lesson, we will be again revising the concept of electromagnetic induction with the help of the problem solving. Thank you very much.